Alright guys, I got a presentation today. It's going to be really informal, and it's going to be filled with all kinds of different information. And I can almost guarantee you, no matter who you are, you're going to take something from this video. If there's ever one to watch, it's this one. I've been watching a lot of videos and seeing a lot of people make mistakes on what's occurring around our planet. So I'm going to break everything down, and we're going to get through all the nitty-gritty details, and I'm going to explain it in a way that you can understand. You more than likely will not find this information on most channels, and certainly not like channels that are like mine, with very small subscriber count, very few commenters. So please try to share this video, especially with people that have issues with chemtrails and contrails and trying to understand all that. People that just like, space and how the Earth works and everything. So we'll go ahead and get started here. What you're looking at is a presentation of our galaxy, and basically it shows how the energy is dispersed in a spiral formation. These are called arms. These spiral type rings that flow around the galaxy that originate from the center. And you'll notice some of these rings have breaks in them. Okay. Now, as the sun passes through, you can see the sun over in this area. And in fact, I got another picture here. We'll go ahead, go on here. As the sun passes through these different arms of the solar system, it changes the entire solar system. Every planet, every moon, and especially the sun. You can see how these rings could represent a time scale, almost here. And you can see it happens every 12,000 years or so. And it's said through calculations that the solar system, our solar system, has orbited around the galactic center only 25 times in 13 billion years. So you can kind of begin to see a picture unfold of a cycles, how these cycles occur. And it originates right here, and how these spirals of energy are released from the galactic center. Different energies, different magnetic fields, different densities of material. So that's how our solar system gets engulfed with these different thresholds of, or boundaries, I guess you could say, of different areas of space within the galaxy on the ecliptic. Now, let's move on to, we'll go ahead and discard that. We don't need that. I got a lot of things to show you here. And we're going to move on to what the sun creates. And it creates what's known as the heliospheric current sheet, which it's also could be called the interplanetary magnetic field or the heliospheric magnetic field, but it's all the same thing. And how it works is on both sides of the sun you have these jets coming out, and then these cones of material, and then you have a central disk that the planets all revolve around. Okay? And as the sun travels through space, it creates a bow shock out in front of this heliopause. It's like a bow shock that kind of shields us from all the cosmic rays that are coming in, all the charged particles. Now, as we've seen at the galactic scale, we can basically see the same thing happen in the solar system. And this is what's known as the Parker spiral. Okay? And in this Parker spiral, you see the same as the galaxy. A spiral of energy that comes out from the sun. And usually it's due to mainly coronal holes that occur on the sun that open up the outer shell, what do you call it? I told you this is informal, so I haven't prepared much. So, well, anyways, it opens up the outer shell of the corona of the sun, and it's a direct path to the surface where the solar winds are much higher. So that's what creates these ripple effects that occur throughout the solar system in a certain time frame. Okay. So when the Earth crosses the threshold, it occurs every 7 to 13 days, I believe. And it causes a phi angle shift. Phi angle shift to the magnetic field of Earth between north and south. North and south. So if you think at the galactic scale, it would have to do the same thing, where the magnetic fields would cause a shift of the entire solar system, just like it does our planet. And that's where we see these changes occur globally through like core samples and geological records of every 12,000 years, every 6,000 years, different time scales, different things occur. You have excursions and all types of things that happen. But this is why it's happening. This is the cause of it, is the galactic center, just like the solar system center of our sun is releasing energy that isn't at a stagnant rate. So it creates a ripple effect, and you have modulation at that point. So that's what's happening there now. we'll move to solar cycles and show you how those work. We're going to discard this, and we'll go find the sunspot observations for the past 400 years. Okay? And in this picture, you can see the modulation occur in the sunspot totals. So you got 1600s back here and present, 2000 area here, 2000s. And you can see the different cycles. Okay. Actually, the next cycles are coming down like in this general vicinity. So we're headed towards another minimum, and possibly a grand minimum like these here. We have our modern maximum where the sun was most active, and that occurred roughly between 1940 and early 2000s is when it started coming down. So this happened, this is the Industrial Revolution, right? Same time frame. And they say that man caused all this warming. Well, that isn't true. This graph completely shows that the sun caused more energy to be placed into the Heliospheric Current sheet, the interplanetary magnetic field, which, let me go back and show you guys another picture. Where's the two? Okay, yeah. So you have the current sheet that feeds energy throughout the throughout the ecliptic for the planets, which more energy added to this current sheet would mean that the field strengths of the magnetic fields of the planets would increase. They would have a stronger magnetic field. So with less energy added to this current sheet, the magnetic field would decrease in strength. Okay? So that's how that works. It's how the sun controls the strength of the magnetic fields of the planets that have magnetic fields. Got a lot to get to, Okay, so back to sunspots. Now this graph, wait, hold on. This graph shows you from 1870 to 2020. Okay, and you can see the modulation very clear here. This goes up, then down, then up, then down, then way up, then down, then kind of up a little bit, and then back down, and headed to levels that were pre-1700s. That's where it's headed, that we can see. Because in the last solar cycle here, the sun's magnetic field went out of phase. Okay, the sun creates a frequency, and this frequency went out of phase in solar cycle 23 or 24, and that's when we've seen this very long stretch of the sun not having any sunspots on it. Okay, that is a clue showing you that it is headed towards a minimum at that point. You have all these clues, and if you don't know these clues, then you don't know how predictions can be made of what should occur. The chances, there are percentages, of course, but what we see, this is what's going to occur. So we get to this here. Okay, in this graph, this is a comparison of the solar cycles, which are here in this top graph. This is the solar cycles, and these are every 11 years. Starts here, ramps up in the middle, and then comes down. That's 11 years at that point. Okay, and then down here at the bottom we have the amount of cosmic rays that are entering the planet and the solar system. And if you notice, as the sun decreases its activity, the cosmic rays increase. And you can see this happen throughout both graphs, almost in unison. I mean, the comparison is uncanny. As it goes up, it comes down. As it comes down, it goes up. Just opposite throughout. So we can tell that since the sun's magnetic field is decreasing, that is allowing more cosmic rays to occur. This is allowing more cosmic rays to penetrate the solar system, to penetrate the planet and the atmosphere, and also the Earth's crust. Now, let's learn what cosmic rays are comprised of. I would say right about there. Hey, I was right. Okay. Now, cosmic rays are high-energy protons and atomic nuclei that move through space at nearly the speed of light. They originate from the sun, from outside of the solar system in our own galaxy, and from distant galaxies. Upon impact with Earth's atmosphere, cosmic rays produce showers of secondary particles, which is called scattering. Okay, and some of which reach the surface, although the bulk is deflected off into space by the magnetosphere or the heliosphere. But that's only true when the sun's magnetic field, the heliosphere, is strong, and our magnetic sphere, or magnetosphere of the planet is strong. Okay. And here you'll see an image of cosmic rays passing through a cloud chamber, which allows us to see radioactive, elements, all the different alpha, beta, gamma, all of it. You can see the cosmic ray coming in, and when it hits a particle, it changes its trajectory and creates a scattering effect of that particle it hit, and then it hits another particle, and just begins a cascading ripple effect through the atmosphere. Okay, now we should move to how the Earth's magnetic field works. Okay. Now here we have the magnetosphere, sorry. And it is comprised of the bow shock, which is here. And then you have the dipole magnetic field, which is the north and south, just like a bar magnet. And then you have what's known as the L-shell magnetic field, which kind of looks like a slinky that goes around the planet. And different rings connect to the planet at different areas. And I'll explain a little bit more about that in a moment. You also have what's known as the Magneto Tail. Energy is stored in the Magneto Tail. So when energy is increased, more energy is added to the Magneto Tail, which is fed into the dipole and increases the strength of the magnetic field. When there's less energy added, again, vice versa, the strength goes down. Okay? Here we have a picture of the L shell magnetic field. Okay? And let me get to drawing here. Now, you have these things called indexes, and these are magnetometers that are spread across the planet at different levels, and they have different names, and I like to kind of explain what they are. Okay. Now, these outer rings, they meet here, the L4 and L5 region. They meet more higher in latitude in this area. And this is what's known as the AE index. Okay, AE index. AE index. Okay. That's 4, that's 5 and 4 roughly. Okay, and then you have L2 and L3, and that'll be your KP index. And then here in L1.5, that'll be the DST, the DST index. DST index. Okay, and that's how you know which L shell is being monitored at which stations throughout the latitudes. Okay, there's some in the south as well. Okay, that's how that works. That's how the indexes work. They work along with the L shell magnetic field. See, I told you guys I knew some stuff here now. And you can go look at all this. I'm showing you, some images and some things, but you can go look at any source you would like, and this will be true for what you're looking for. Okay. Now, once this energy is fed, here, let me show you something real quick on here too as well, because I did want to mention something. Out here, along with this bow shock, basically, you'll find what's called the LLBL. That is the lower latitude boundary layer. That's how energy is fed back into the system when it hits the magneto sheath of the planet. When it comes in from the sun and from the galaxy. Okay? LLBL. So energy comes in through the IMF, it hits the magneto sheath, and it flows inward to the LLBL, and then it's fed into the L shells. Okay? That come into the planet. Now, moving on to how the energy is dispersed on the planet. Now this is all gonna feed into how contrails work and how other things work. Okay? So what we have here, let me show you this picture. This is the bow shock. Okay? Bow shock's out here. Bow shock's out here in this area. Sun's in the middle, planets are orbiting around here, and then you have a ring current that runs around the middle. Well, the ring current is around our planet. This is the solar system. So excuse me, I'll have to fix that. That's the ecliptic, right? And then you have the heliopause, which is the outer shell, which protects us from the cosmic rays. And when its strength is down, it allows more, instead of bouncing them out, it allows more to come in. And this is the heliosphere. You got your Parker spiral in there that spirals the energy outward. And that's that. Okay. Now as the energy comes in to the planet, it follows the Birkeland currents, and it follows the Hall's and the Peterson currents. Okay? And these currents, these are the Hall's currents, okay? And they basically are it's like a meridional flow, like the sun does. This is what creates the flow to head towards the middle and latitudes and the equator. Okay? And then you got the Peterson currents that run it this way, and they come in a certain way and they leave a certain way. Okay, are you guys seeing these pictures unfold and how this all works? You got your storm systems that work out of these low and high pressures from these inwards and outwards movement of the current, right? And it shows you the night side and how the current runs from the magnetosphere, the magnetopause inward, and comes back out and around, and it's just a loop, just like a bar magnet, feeds itself, and some escape and some stay, and that's how it works. Okay, so you got your Peterson currents and your Hall currents and your Birkeland currents, and then you have a ring current that goes around the planet, ring current. Now, this will show you how the currents work coming in and out. They don't just flow in a straight line and out. They swirl. Okay, and the swirling effect is modulation. That's how you get your differences in jet stream flow and different storm systems and uplift and all sorts of things happening. And then you have all your electrons and all the particles and things that are flowing, and that's when you get your aurora and how all the system works here. So now that we know how the magnetic fields work of the sun and the earth, we're going to move on to how the cosmic rays and that increase of cosmic rays here in the modern past. We'll go back to this graph here. Okay, so during this modern maximum, we had less cosmic rays. Now we're coming down, and we're down here now again, right? Which are down in this area. This Dalton minimum is basically where we're heading to. Okay, and that, since the sun has decreased its strength, this is allowing more cosmic rays to come into the planet, like that. It's increasing, this is decreasing, so this is increasing. So what do the cosmic rays do? What do these cosmic rays do when they enter our planet? Okay. Well, as I mentioned before, they scatter. Okay, they create a scattering effect when they enter, because they're entering at near the speed of light. And what it does is it smashes into these particles and breaks other particles and causes them to spread out and hit other particles and scatters, basically like a chain reaction. And when this occurs, this causes a cloud nucleation to increase. This promotes clouds to happen more. So it changes the atmospheric conditions of what's occurring up there. Okay. Now I have a graph of these, there it is, how this occurs. And these cosmic rays, they come in up at the top, okay, and they strike this air molecule, okay, they strike that air molecule, and then it has the scattering effect of hitting particles and changing into other particles because energy is released, and it's split and it creates photons, which is light, gamma, and you have muons, which are double electron pairs. They're heavy elements, and why they penetrate so far. So you have cosmic rays, which are comprised of protons and neutrons and alpha particles and muons. And these muons, they can penetrate even the planet. Okay? So not only do cosmic rays create clouds, they also penetrate the planet, and they cause an increase of volcanic activity through magma intrusion, which is just an increase in energy, and it causes magma to flow where it normally wasn't, and you just have more volcanic activity all around. And if you check the volcanic activity in the past decade or two, you can see a massive increase right along with the increase of cosmic rays. So we are seeing how this system really works and how it unfolds in real time. We are learning so much here in the last few decades that we didn't know before, and now we're starting to understand some of this stuff. But some of it's we're having issues with dark matter and all sorts of things that people are guessing on. So I try not to bring you things that we're guessing on. I try to bring you things that we know and can be verified. And you can verify everything I'm saying here. Find your own source. Just break it down sentence by sentence, and you'll find everything you could ever need. Okay. So, as these cosmic rays come in, they create cloud nucleation, which are small particles, typically 0.2 micrometers, right? Or 1/100th the size of a cloud droplet, on which water vapor condenses. Water vapor condenses, okay? So it creates these seeds that allows water vapor to condense easier and gives them something to attach to. Water requires a non-gaseous surface to make the transition from vapor to liquid. This process is called condensation. Okay, it's a very simple process. We all know it. Cold drink on a hot day. You know how this works. Okay. Now, let's see if we can find volcanic activity. Okay. Influence of cosmic ray intensity modulated by solar activity and volcanic eruptions on the climate. Fantastic paper, goes through all sorts of different things. Cosmic rays, obviously, solar activity, obviously, volcanic eruptions, and how it affects our climate. Okay, we are headed for a cooler trend. So we're having an increase in volcanic activity. Okay, which explosive volcanic eruptions triggered by cosmic rays, by the bubble chamber. influence of the muons. Okay. Volcanoes with silica-rich and highly viscous magma tend to produce violent explosive eruptions that result in disasters in local communities and that strongly affect the global environment. I'll let you guys go ahead and read that. Cosmic rays, muons. Okay? So, now that we understand how the Earth's system works and how these cosmic rays are increasing cloud cover, okay? Let's see here. What do we have for you? We got something here. Where's the volcano erupting? Stick with me. I did this on the fly really quick, so just so we could have some information. If you guys see it, holler out. Okay, I don't have it in this one, but I wonder why it isn't in here. Strange. Okay, so you have these cosmic rays coming in. Okay, and they're coming in up here, and they're hitting these particles. Okay, and it causes more clouds to occur. And you're probably going to find more electrical storms because of this induction of energy from cosmic rays and at the speeds that they're hitting. Okay. So, now we'll move on to what we're talking about here. Okay, you have, get to where I can write here. Okay, we know things occur. Okay, we know volcanic activity sends sulfur and particulates of various things, you know, silica and all that. And those particulates and sulfur, they promote clouds to occur along with the cosmic rays that are coming in. Goodness me. Along with the cosmic rays coming in. Okay? These aircraft are flying through the same natural system that these volcanoes and the cosmic rays have to follow. There's laws. And that is exactly why these trails are persisting longer and why they are spreading and flowing into actual cloud systems more than they used to back long ago, back in the, you know, the 60s, 70s, 80s, 90s, when the sun was really active and it was a different atmosphere. There was different conditions than it is today. So that's why these trails are persisting longer. And I can't believe Neil deGrasse Tyson hasn't explained this yet. The same reason why these cosmic rays from the sun and from the galaxy, they cause clouds to increase, then it's the same reason why these planes here and their trails are staying longer and spreading out more. That's why. Because they're adding particulates of soot, okay, and actual water droplets, which is what the system is trying to make anyways. Pulling moisture in. The low and high pressure systems. Uplift of air. And that's how the system works. So that's what's occurring. They are not chemtrailing. Normal commercial aircraft is not a chemtrail. Okay? So I hope this has explained some things. I hope this helps some people understand exactly what's going on and can now speak to it and understand it and share it with other people to understand what's exactly occurring up there. The conditions have changed, not the airplanes. Okay, let's get that straight. The atmosphere has changed. Where the airplanes are flying through, that has changed from years ago when we were children and when our parents were children. That's why. This is exactly why. So, please leave a comment below. Tell me what you think. I challenge anyone to challenge anything that I've said here. And if there was a mistake made, I have no problem correcting it, but I do believe I've pretty much hit the nail right on the head. So tell me what you think, and there should be another video here explaining what geoengineering is and what should be considered a chemtrail. Okay? But as for commercial airlines, those are indeed contrails, and why intelligent people understand this information and can tell you that that is a natural process and isn't something nefarious. Okay, guys, stay informed. Stay positive. All right, love you guys. Bye.